today's topic, let's get rolling. Even some people might join still, but today's session is about the Platform of Trust next generation connectors, which we prefer to use the term V2, version 2. And I did some a little information for you to know that in why are we even here and what's happening, and why this version 2 is now the thing. So probably everyone knows that we have had the platform up and running for a while at least, and we have onboarded some customers, not too many, because that was a selection by us. We didn't want them to be there flooding instantly, to make sure that the customer experience is good enough, and we can develop all the necessary processes and components and everything to provide the best possible experience. And that's why we have onboarded enough customers to learn what works and what doesn't work. So pros and cons of the current solution. And based on the learnings during the summer, last summer, and even late in the spring, we started to do some experimentations on version 2 connectors and a new architecture, because to enable, for example, streaming data products, we had to adjust the underlying architecture, and that's why we need to build more capabilities on that side as well. So it's not just about the connectors, but it also affects our architecture, and we had to make some moves over there as well. And we still have to develop the version 2 architecture in parallel with the connectors, and those two have to be aligned. And that is why we are having this meeting in which we have the both sides. So you will get an overview of the version 2 architecture of the platform for the parts that actually matters at this point, and then we will discuss also the version 2 architecture of the connector component itself. And as I mentioned, the version 2 of the platform is implementation has started now after the summer, because the summer experimentations and springtime planning were finalized, and now the one of the increments of the program started like a week ago. And the aim is that starting Q4 this year, 80% of the connectors should be developed on the version 2 architecture and version 2 connector architecture as well. So gradually make a move towards the new architecture as fast as possible. But still, if needed, and some of the customers in the version 1 architecture still might need some connectors, those will be developed. But we try to push the new customers to the version 2 architecture and connectors, and obviously at latest starting beginning of next year. That's the rough plan, and that's the reason why we are here. And we want to align the connector development with the architectural plans that we have, and to offer all the connector partners and some organizations lurking around the connector engine an opportunity to view what has been done and where are we actually going to, and who actually knows about what. So this is a plan to opportunity to see more details about the Platform of Trust development and components and architecture and so on. And based on that, I did an agenda that, hey, welcome, and why we are here. I just did it in time, and even with the additional discussions in the beginning. And then there will be Adrian from Zure, who will tell us what was done exactly during the summer 2020, and show and discuss the necessary parts of the Platform of Trust version 2 architecture for us. Not everything, but the needed part for this to understand the connector development, and also some significant parts of the new data product capabilities. And then Arto from Polku Innovations. Basically, Polku Innovations has been the primary partner actually to develop the connector architecture from the beginning and they've been doing that and leading that development. And Arto will discuss but the changes and the effects of the version 2 connector architecture for us, and possibly show us an overview of the code level implementation. Not exactly the code, probably we don't have time or need for that, but at least what is the logic of the architecture and in how it's built basically, and how you can actually reuse components and features in it to speed up the development. Then we have time for questions and answers, and then the next steps, what's gonna happen, and that's what's gonna happen. Any comments? Anything else from your side, or should we actually let Adrian take the show? Probably not. So I hope Adrian is here already.
I am, but Jarno is probably doing the actual most of the speaking. I'll try to show a demo if I can get PowerBI to work. Wow.
All right.
Nice.
Yes. Yeah. Hey everyone. So I will be doing the initial kind of a presentation about what was done before the summer and the actual architecture, and then Adrian will do a demo. We don't have that much things to speak about, I guess, but let's start. Let me share my screen just a second. I'll zoom this in like that. All right. So we have revised the earlier architecture a little bit. Sorry about the bad drawing. It's still, we need to finish it up by cleaning it a little bit, but the idea is basically everything is here that needs to be. I'll just change the color for this one. All right. So my first question is that is everybody here familiar with the original V2 architecture plan we had? Or should I go through the kind of the basic idea behind the version 2 architecture?
I would say that, hey, take a brief overview again, because there are some people probably not familiar with the plan.
All right, yeah. So basically, the translator V2 architecture, the idea behind that is splitting the different parts as independent services. So you can probably call it a little bit microservices based architecture, but it's not quite that heavy that usually is kind of understood when talking about the microservices. What we have here is on the right hand side, we have the client being the platform of trust user, the actual developer or application or organization who wants to consume the data. So this is the client. I'll change the color here. So the client requests data. Now in the current, let's say V1 architecture, the client needs to do kind of a standard way of doing a request response cycle to actually retrieve the data. So the client sends a request to the broker API, and in that request, the client defines what data he wants to retrieve. And basically the request goes through the current stack, and then after a while, the client gets a response back. And there's all kind of stuff happening behind there, mostly harmonizing the data and then passing it on to the client. And of course, there's the graph database and stuff like that. But what was the original kind of main point for the new translator was to add the capability to actually stream data. So instead of actively requesting the data, the client could then just receive the data whenever new data arrives. So that was, we have done a proof of concept type of implementation with Polku about that, and it is working. And that is something that Adrian will demo. after this. So this is the translator V2 here. And now we are in a pretty good shape regarding the proof of concept implementation and how this whole stack is working. It goes a little bit like this. We still have the original way of requesting the data from client, and basically it goes through here. It starts on the client. He does a request. It goes through the API management, which is currently being actively worked on by the core team. So they are setting up the API management, doing deployments there and configuring the actual APIs. And the API management is there to add additional security and, of course, all kind of features that come out from the Azure API management, one being developer dashboard. The request goes to API management, and then it goes to the actual APIs, which are whatever services are behind. Mostly currently there are Python-based APIs running in clusters. And from there, the APIs are meant to send or actually publish a message to service bus.
No.
So whenever a request comes, a message is then sent to service bus, and then based on what data is required, there's some home discussions going on. But yeah, so basically the APIs publish a message to service bus, and in that message is being told that what is needed. Then there's a connector, which in this picture is imagined as an Azure function. The function is a standalone connector, and you would have one connector most likely per a data source. The connector then reads or receives the message from service bus and sees whatever data is requested by the client. And then the connector is a component responsible for actually retrieving the data. So what connector does, it basically connects to the data source and then gets the raw data back. And the connection can be whichever way it is. It is probably some API here, or maybe a direct database access, or maybe the data provider sends the data to connector. It's not actually, that scenario is not in this picture. It is in original translator V2 picture, but let's skip it for now for the sake of clarity. So let's say the connector retrieves the data from here. And what is next is that the data needs to be harmonized. So the connector publishes the raw data to service bus, and then a transformer receives the message from there. Basically, the transformer takes in the raw data from the data source, retrieved by the connector, and then it does the transforming, the harmonizing of the data. And when that is done, it is then once again sent to the service bus, and then whichever service needs to send it out picks the message up. So in this case, request response cycle, it is the application APIs. They receive a session-based message for the data, and then they basically push it back to the client as a response. And then, of course, the connection is alive for the whole time. And with the session-based messages, we can then send it back to the client without closing the connection. So the client actually sees a normal request response kind of a action for the data. And we have done a demo for that one also, and it worked pretty well. So it has been kind of proven that it works, but there is currently no production level implementation for this request response type of events. But everything is good to go in a sense that the whole stack supports this use case. But then there's this streaming option, which was the more important one in this translator v2. And how it works is that the client defines through a web-based interface some kind of a stream request. The client defines what data he would like to receive, and he also defines where that data needs to be sent, and we call it stream hooks. So a client basically tells the configuration database that I need data from, let's say, data provider X, and I want it to be sent to this specific stream hook. The stream hook can be HTTP-based API endpoint, or maybe some Signal or type of endpoint, or basically whatever the actual streaming outbound functions support. Then the whole kind of a cycle goes in the same way, with the exception that when you define a streaming as a client, you need, of course, some kind of a trigger for that data. The trigger can be a timer based. If the data provider only supports retrieval of data, then of course the actual connector needs somehow to do a timer based request to retrieve the data. So let's say in case of lean heat, they cannot push the data to this POT stack. Instead, there is a function which is timer based. It retrieves the data from lean heat every, let's say, 5 minutes. And when the new data arrives, the function stream manager is responsible for checking that, okay, this data now needs to be sent to some stream hook. And it all works through the service bus. When the connector gets the data and it has been transformed, the transformer publishes the transformed data to the service bus. And the streamer, when it has subscribed to the service bus, it can see that, okay, there's now new data available to be sent to a specific stream hook, which the client has defined that I actually need this lean heat data. And then we have this function stream manager, which is responsible for checking that, okay, this data needs to be sent onwards to some stream hook. And then we have here a content negotiation, which receives the transformed data, and it then basically renders the data as an XML or JSON or whatever format is needed by the client. And then we have the outbound functions, which are basically same as connectors, but they just go outwards. So they then pass the transformed and negotiated data back to the client, to the stream hook. So the timer-based connector is one option to do this. Then another option to do this is a push-based data. And this is what we have actually done with Polku. So instead of periodically retrieving the data from the data provider, in Polku's case, they send it to the Platform of Trust. So Polku has an external connector and transformer running in their systems. So the connector and transformer are not actually required to be in the POT stack at all. We do have an inbound API, which takes in either raw data or already transformed data. And then based on that, it either sends the data to the transformer or directly to the streamer through the service bus. If the inbound API receives transformed data and it is valid, basically the inbound API needs to do the data validation. But if it receives a transformed data, we know that we don't need to basically bother the connector or transformer with that data. We just send it to service bus, and the streamer figures out where it needs to be sent, and then the content is negotiated again, and then it's sent once again to stream hook. And there is also an option to only have external connector. So let's say Polku doesn't want to do the data transforming for some specific data source, then they just are responsible for retrieving the data and sending it through API management through the inbound APIs. And when it's raw data, it publishes a different kind of a message, which is then sent to transformer. Transformer then basically harmonizes the data, and then it goes to the streamer again, and it is negotiated, and then it's sent to stream hooks. So there's kind of these two scenarios where the connector and transformer can be in the actual platform of trust environment, or they can be hosted by some third party completely out of platform of trust environment, and they can send the already processed data to POT environment, and then it goes outwards. So that is kind of the bigger picture here. What was done before the summer is actually this part. So this is what existed before the summer, and right before the summer and in the first weeks of the summer, we got this one working with Polku. So Polku did a great job with setting up their connector and transformer, and they are sending us the transformed data, and then we are passing it onwards from there. So this has been tested, it is working, but what is basically has not yet been tested is we need to find a way to host these connectors and transformers in here. So there is probably a requirement that connectors and transformers needs to be, in a sense, controllable by POT, and that developers, let's say in Polku, can do maybe an NPM package of sorts and then just deploy it through the CI/CD pipeline to POT environment. So in that way, there are developers who don't need to actually host the connectors and transformers themselves. They can, because there is the inbound API, but there should also be possibility to only build these and then deploy them to the POT environment. So that is something we haven't yet figured out, which would be the most developer-friendly way to do that, but it is something we will probably work on in the future. But yeah, I guess that's mostly about it. I don't have anything to add at this point. I hope I was clear about how it should work. So if you have any questions, feel free to.
I can comment that this is just marvelous. This is amazing. I'm happy. This is exactly what I wanted and what I talked about. And finally, I see that it actually becomes a reality. And even I understand what's happening here. So you were clear. Nice. You were clear. Although nice. I've seen these pictures like 10 times and having the discussions like 5 times earlier, but still. Yeah. And yet, again, I stress the importance of having Polku as a partner here. They actually did a significant part of it and makes a lot of things possible. But the Zure's work has been great, and I have nothing to add. I think the last part that you mentioned that has been discussed during the spring already, and in the Q2 at least it was in more detailed discussions already internally. How would actually do the developer friendly way of getting the connectors and translators deployed in our environment. So far we've been using the containers. But some kind of process has to be involved, and if those are node-based, then it's the NPM is possibly the best way to do it. But I don't see that as a problem. It's just figuring out and discussing what the process is, and so that security and everything is taken into account, and that's it. So it's not, as you said, it's not solved, but it's not a dead end. It's something that we just need to figure out.
Yeah, I agree completely. Indeed, it's not a deal breaker in a sense that we do have kind of the building blocks. We just need to test which would be, as you said, the most safe and friendly way to actually do it. It needs to be super easy to actually push the stuff to POT environment, but to do it safely in a sense that nobody cannot send any malicious code to POT environment and so forth. But yeah.
Also, a quick question from my side. So if the goal is to move the external connectors and transformers, so the components built by third parties into POT, then I no longer understand what's the goal of the inbound API. So if those components will be moved to POT?
No. Not everyone. The thing is that probably 80% of the connectors will be inside our, at least in the beginning. So we will host those, and some of the customers, depending on their plan, get it for free, and some of them have to pay a monthly price for it. But some of the connectors will be outside.
Okay, that makes sense.
We need to provide the both opportunities, and that's what's drawn in the picture as well. So that's the reason. So.
Okay, clear. Thanks.
Also, I have a question. So in terms of development, what will change for the developers who will be developing the V2 architecture connectors if they're hosted inside of Platform of Trust? So what are there any major changes to the development itself?
Should we actually go through the second the demo and the second presentation about the connector V2 and architecture and everything, and then have the discussion, because this is related to how Polku's work as well. So what they have done. So does it make any sense to go through now all the parts, and then we see the whole thing, and then we can ask the detailed questions?
I think so, yeah. It is pretty heavily tied to the Polku's architecture, the actual internal architecture of the connector and transformer. So yeah, that's a good idea. So maybe we will move to the demo and then take Polku on stage.
Yes.
All right, great. Adrian, it's all yours.
Yeah, okay. I'll start sharing my screen and hope that Power BI is not kicking me out. Yeah, I'm not a Power BI expert, so it's an ugly demo in a sense, but I'm just pressing refresh and kind of showing that data is coming, as soon as it's, available. But I'm having problems with Power BI because I'm using it wrong, so I'm getting kind of too many requests. I'm pushing data in a wrong manner from the Power BI perspective. But it's moving in the sense that, for example, we can see that our API is receiving data from our live metrics and looking at the Azure functions which are communicating with the Azure service bus. Things are moving, except that, as always, Azure metrics is not showing in real time as I wanted it to show. But yeah, it's moving. There's it's moving. The data is moving. It's hard to show the stuff when Power BI is kind of giving me certain kind of errors while I'm pushing data.
So the data is coming from Haltia.
Yeah, it's coming from Haltia and it's going through the picture that Jarno showed us. So it's just a little bit problematic because I'm pushing data all the time to Power BI, and Power BI says to me that, hey, you're pushing too much data for me. You have to kind of batch it together. And it's I don't know how to use it properly, Power BI at the moment.
That's why we have different people for that. But again, not your problem. But the point, it actually comes through the whole system, Platform of Trust, that it actually goes to Microsoft PowerBI, and that's it. And that's the idea.
Yeah, and I hate it when Azure does this. Yeah, I've lost the connection to the to the live metrics. I wanted to show on the right side of the screen that stuff is moving, but now it's just dead. So yeah, it's always fun. But yeah, it's still moving. It's just not the prettiest demo. I don't know how to make it prettier. Yeah, I don't have anything else at the moment. It's just this is basically the data is coming through the API. It's as you can see, it's constantly moving. That's working, but the Power BI is a bit problematic for me.
I know that Ezra is online, and Ezra is our data analytics person or expert. I think. Do you have any questions or comments or anything on the Power BI side and usage of our data products in Power BI?
I just hi. I just noticed there that the timestamp was added to 7:33 to 7:36, and if it's live data, shouldn't it be like right now? So that's why it's not showing the whole thing.
It's actually probably showing the GMT-based timestamps. So if you add 3 hours, it should match.
Okay.
Yeah, probably.
But anyway, the next step is to actually, my plan is to match the people who actually made this raw data example possible with Ezra, who's the actual expert on the Power BI side. So Ezra might be able to let's say optimize the things and then tell a little bit more how it should come from our system to Power BI so that it would be easy to consume and to reuse in templates and so on.
Yeah.
And we have already I am already having a meeting with Ezra about the subject, and after that meeting, I'm gonna take all the people together and make a plan how to go forward.
Yeah, but yeah, I'm just again the same error as but this is my problem. I don't know how to use Power BI correctly. It's kicking me out. I'm telling me I'm sending too much data to it. I don't know what I'm doing wrong at the moment.
At least it has started. Then we will see how we fix that.
Yeah. But
you're a spammer. So.
But you know, you can see that the data is going there. It's just telling me that you can't send me that data. You're doing it wrong, basically.
Yeah.
But yeah, the data is moving there. I just Power BI doesn't want to work with me. Yeah, but yes, I don't have anything kind of cooler to show. This is it from my side. Apologies for the demo problems, but I don't know what to do with Power BI.
No problem. I at least I know that it works. And I know that it's not your expertise area, and that's why we have Ezra's and so on to work on the other end. So your part was to actually do it together with Polku so that the data at least flows, and then we can solve the rest of the problems with Power BI, with Ezra and so on. So no problem.
Yeah. Anyway, thank you, and I'll let the next person continue.
All right, any questions to Adrian or Jarno about the platform version, architecture version 2 or the data streaming demo? Or should we actually go to the version 2 connector architecture with the help of Arto from Polku Innovations?
Hi everyone, this is Sergio here. So just to clarify from the picture that Jarno showed, it seemed that the external translators that could also be transformers would only work with the streaming capability of our platform, but will still work with the request response type of architecture. So basically, a request response right now, when we have internal connectors, those will put a message in the message bus, and that will trigger our internal connectors, and then the flow will go from there. But will it work also with external connectors? So basically, when a request comes in and this is put in a message box, in the message bus, if this can go to the external connector as well.
Yeah, it can be made work, but I guess the biggest problem there is that the external connector or the external hosted services need to have some kind of way to trigger the actual data sending. It is otherwise pretty hard to actually match inbound live data with what is or what should be going out, because the request response is kind of the client can do it whenever they want to, but there is no guarantee that there is actually data coming in at the moment. So for request response cycle, if there is no data cache or data storage of any kind, it's kind of the issue is more of this kind of what data should you send to them? Should you always retrieve a fresh data, or should you send them the latest received data from the external connector or transformer? So there would need to be a way to trigger a new set of data to external connectors. If they do have some kind of a mechanism for that, then it's not a problem to implement it also for the request response type of flow. Then it would mean that whenever a request comes in, the internal platform of trust connector then trigger the external connector to retrieve the data and transform it and send it back. And when we do have request IDs, we have the sessions, so we can freely basically tie actual data to the response, but it's only about the discussion and the decision what data should be sent back. I'm not sure if I explained that in a sane way, but unless there is a data storage, when you have periodically inbound data coming in, then it's hard to decide what needs to be sent back to the original requester, because they want to have some specific data. If you do not have matching data coming in right at the moment, then it's kind of hard to do it without actually triggering some kind of a sending mechanism for the external connector. But technically, it's totally doable.
Okay, so basically this only brings a design complication at the external connector, so that also supports this scenario.
Yeah, it adds additional requirements for the external connector. You need to have some kind of an inbound endpoint that can be used to actually request a specific data to be served out to the kind of the original requester. So then, yeah, it would work. But if you do have some kind of data cache, then of course it would work without any issues, because then you can just retrieve the latest data.
Okay, thank you.
All right, thank you. Any more questions, or should we let Arto go on with the connector changes and development? Yes, let's go forward so that we don't run out of time. So Arto, please go ahead.
Yep. So I guess you can see my screen. Let's put it full screen.
Yeah, good.
Yeah, so hey, thanks Zure for the demonstration. It's nice to see that there's data streaming through the service bus and it's coming from our connector. So yeah, I'm Arto from Polku Innovations, and we've been developing connectors for Platform of Trust and been also involved in the development of version 2 architecture, and we really appreciate this. So I can show you how this affects connectors. So I have 3 topics. First, really shortly about Polku, what we do. Then about the overall architecture, because I think it's good first to understand the interface between Platform of Trust and connectors. And then third, the connector logic, how the connector works, and also in detail how does it look in code level. So let's begin about us. So at Polku, we write a lot of code, mostly Node.js. Our focus is in the field of smart buildings, and it's mainly routing, streaming of data, storing it, and utilizing it in the context of built environment. So we are familiar with all the technologies involved in Platform of Trust. So I think that's like we are doing a job we know how to do. But let's go to the main topic. So first we had the first version of Platform of Trust. It has identities and they form a network. They are linked to each other, but the special thing is the data product. When an identity is linked to a data product, which can be, for example, temperature from Siemens Mindsphere. So then this sensor is linked to this data product with an ID from the external system. And because of this link, data can be queried from the broker with this external ID and the information about the data product. In detail, it's a product code. So we take certain data from the identity network and make a broker request. So these are the parameters that the connector gets from the broker. So the broker validates that it's a valid data product and knows which URL the connector is hosted and can forward the parameters to the connector. And in the connector side, because there are so many data sources, they use different protocols, authentications, and even the format of request response is different. It needs to do certain things to be able to get the data. It needs to switch to the correct protocol, authentication, and then it needs to handle the request and response in the specific format. And lastly, it needs to harmonize the data. And as we saw, this harmonizing can be also done after the raw data is received. But we can see in the next slide that how this changes in the version 2. So I have here the same picture that Jarno showed. It's a bit simplified. There is the streamer and the service bus described, but in here we can see that Jarno talked about the hook subscriptions. I have here these subscription requests, and this makes it possible not only to query the data, but make a subscription to receive updates on those specific external IDs. It follows the same logic that the data is requested with the parameters, but the application puts also a hook URL, a destination where the data is streamed from the streamer through the service bus. Some data sources support streaming, so the data can be easily routed directly to the streamer. And this is the case 1 we tested during this summer. So we can just define in the connector that when it receives data from the data source, it will broadcast it to the service bus. And from there, it will stream it to the streamer, and the streamer decides who wants to receive this data. So this is the simplest version. But then you also saw this triggered version. So now with the current situation, if we want to trigger the querying of the data, we need to use the broker to send the parameters and get the latest data. But of course, as we discussed, this connector could be in the same environment as the service bus, so they could have an internal connection to do this scheduled data fetching. But on the next slide, I have more about the connector, what's the inner logic. So let's see that. So the flow inside the connector, it has 3 parts. This is kind of the simplified version of the flow. On the next slide, I have more detailed version, but I think this is the way to start to show it, because it's easier to understand how connector works. So first, it receives the broker request. It is authenticated that it came from the broker, but then it will configure and send the request to the external system. For this, it needs the protocol switching I mentioned, and then also authentication and some options required by the specific data source. But the request is sent, and then it comes back. And after it comes back, it needs to be parsed and then harmonized. After this, it can be returned to the broker and then to the application. So this is the request response logic that has been used from the start. Part 3 is for external systems that support real-time streaming. It listens for data and can broadcast it using directly the part 2, because it doesn't need to make the connection or request the connection. It can just skip to part 2. So with this part 2, we have now in this POC done that whenever Haltian sensors send data through MQTT, which is a real-time streaming protocol, it can just go to the part 2 and broadcast them directly to service bus. And the service bus will, of course, then broadcast them to those hooked URLs it has in the subscriptions. And we can also see that this one simplifies the flow quite a lot, because there's none of these request steps that need to be done before sending the data out. So this is kind of really good simple flow to send data. But let's see more specifically what is involved in the steps. So in this picture of the flow, we see all the steps in detail. So this is something that's our own concept of multi-connector. It means that the connector can be configured to serve multiple data sources by only using environment variables. So then it's not like you always have to write a new code to make a connector for different external systems. With this concept, we can just write a configuration and the connector connects to the next data source. And in this concept, every product code of a data product has a matching config in the environment. This data product config defines the parameters with reference to a specific template. And in this template, it's described which protocol to use, and then also which plugins are required in the process of retrieving the data. These plugins are kind of like external libraries, for example, for the authentication, because you have many authentication. Even in REST, you have OAuth 2, basic, API key, OAuth 2 1 and 2. So it is reasonable to package these into simple libraries that the connector can just switch to a different authentication based on the data product. And also with this concept, every broker request is handled individually. So it can broadcast data from different systems. And if you're interested more, you can check the source code at Platform of Trust GitHub. It's hosted there, it's open source. You can see how this works in the code. It's a bit complex. It needs a bit investigating to get familiar with the concept, but it is this kind of stack that follows a static phases. Only the phases use dynamic libraries and dynamic parameters to go forward, but it's made that it has like clear steps. So it would be easier to understand also. I hope you got a good overview on this topic. Thanks for listening. And if you have any questions, just go for it.
All right, now's the moment. Now's the moment for questions more on the architecture of the platform or the connector itself. So this is the QA now. Open your mouth, and let's say that we have 15 minutes now. And if needed, we can arrange another session for more detailed questions. And keep in mind that this is recorded and will be shared for everyone to view again, so that you probably might get more questions in your head. And you're always welcome to ask me, contact me in email or otherwise, and ask again, and I'll get the details. But now's the moment to discuss more on the version 2 architecture of connectors and our platform itself. So go ahead.
Hi, this is Nazia. I actually have a question to Jarno. Jarno, the architecture diagram that you showed, and it was about the streaming data. So what do we understand that there can be like outside of Platform of Trust connectors or translators which can actually transform the data from raw to harmonized and then send it directly to the bus service, which is designed within the Platform of Trust. Am I correct? Then from Platform of Trust side, we don't need to harmonize it for the second time.
Yes, no, oh, now I found my mute button. Yes, basically if the data is already harmonized and it comes in through the inbound API, then there is no need to actually work on it anymore, and it can be directly sent to the requesters or the stream hooks. Yeah.
Is the stream hook like when we send the request, do we actually like ask for the harmonized data from the external system itself, or the request contains something different to indicate this thing?
How it was planned is that in case when a connector or transformer is hosted outside of the Platform of Trust environment, there would be separate inbound API endpoints. And based on that, where you are sending the data, we would already know whether it is harmonized or not. So when receiving the harmonized data, it needs to be validated. So there needs to be a data validation. That's why there would be separate, basically, endpoints for raw data and then harmonized data. And if the harmonized data is already valid, it can be sent onwards to the actual data receiver. And if in case of raw data, there would be probably some initial verification that everything is correct, and of course the security features. But then it would go to the transformer and it would then harmonize the data and send it onwards. So we would know based on the place that the actual data sender is sending the data to.
Okay, all right, now it's clear. Hey, thanks.
No problem.
I actually have a question about the version 1 connectors. Is as I see this, because of the version 1 connectors right now are basically just supporting request response kind of data. Just to clarify, is there already some kind of like a proxy that basically takes the publish subscribe events, requests the data from the connector, like the version 1 connector, and then publishes the result back to the message queue? Or have you thought about that?
Yeah, I'm not completely sure I understood the whole flow.
The idea that I had, that the version 1 connectors would basically, there would be a proxy kind of element in between that would listen for the events on the Platform of Trust side. And when it receives the event, it actually talks to the connector and then sends the response when it gets it from the backing data source back to the message queue. And that way the proxy would also handle the scheduling of basically sending the requests through the already built connector. And then when it gets the response back, it would then send it back to the message queue and basically stream the data. So the version 1 connectors wouldn't need any changes to support that.
We haven't tried to reuse the existing connectors basically at this point. The one Polku has already implemented, which supports the streaming. It did need some minor tweaks to make it work, but if I have understood correctly, it was a version 1 based connector originally. Was it, Arto?
Yeah, and that's a good question, because in our point of view, the version 1 connectors can be used if they are triggered. But this triggering is not the one thing we have solved already. It's something we need to test and see which is the correct solution for this, because it will require some proxy or something that it can fetch the data from an army of connectors. So it needs to be optimized, because if you just start sending scheduled requests, it will flood. So it needs some structure that has not yet been designed well enough.
Yeah. The triggering thing is also a little bit something that was earlier discussed about whether the whole external connector and transformer thing can be used in the request response thing. And yeah, that is kind of the root of the problem, that the connectors need to be triggered from outside somehow. And basically, if we can find a solution for that one, then it also would kind of help with this other use case. But the good news is that even though Polku did change the triggering mechanism for the already existing connector, it did not need that much of a work. So even though some connectors would need to be kind of refined to work with this new thing, I guess Arto was able to reuse most of the original code. So he changed the triggering mechanism, which is, I guess, it is now timer based, or how it is working.
Yeah. In Haltian case, when the connector has already subscribed to the MQTT, so now the thing we change that whenever it receives updates, it can stream it to the service bus, so it doesn't need any triggering. But of course, the next thing would be to define how to trigger the requesting if it's not this publish subscribe type of connection.
Yeah. So yeah, I guess the answer for that one is that yeah, it can be done. Needs a little few thoughts to be given for that thing, and the major kind of a obstacle there is just to figure out how to trigger the V1 connectors, because they are now kind of a supporting different kind of a use case. But in any way, the amount of code that needs to be changed, it doesn't mean that the whole connectors need to be rebuilt from scratch. So it is mostly an issue about the triggering those connectors and then sending the data out. So the actual logic otherwise should remain the same. But yeah, good point.
Also, a quick question from my side. Would it be possible to try to design a generic transformer? So something that is not particular to each connector, but something that is generic, a unique component, and that handles the translation for all external data sources based probably on an input or something like that, or config?
Yeah, a good question, and definitely it is possible. It is doable, and we have already with Adrian, we have played with the idea about kind of a one transformer handling everything. So I think it's more about a later discussion about how this whole transforming thing should work, in a sense that you need to define some kind of a mapping rules for the transformation to happen. You have an inbound data, you have raw data coming in, it's in a specific format for each connector or data source. And then you have, of course, the harmonized model that you need to kind of transform the data to. So it's a more of this configuration-based problem that you need to define that take this data and transform it into this format. So,
absolutely. I guess one of the major problems would be even measure units, because you might have different measure units and transformations.
Yeah, and then there's also the forever standing question that who should do it? Should the developer be able to do the mapping of the data? So wouldn't it be cool that you would have, instead of developers, you would have a more of a business related person who knows the data, who could
that's the next
then
step.
then basically define that, okay, this field should map to this field and so forth. So instead of kind of always having to require a developer to do these transformation rules, somebody from business side or maybe somebody else can do them. But this is kind of what we then kind of faced a wall with Adrian, was that this larger discussion about who and where and how and all that kind of stuff. But yeah, definitely can be done. But it is something that needs to be planned pretty well to make it work. But I guess the initial version would be to do a single transformer and then support some kind of a mapping configuration files for that one. So that way you would instead, the developers could then just configure the transformer instead of developing one. So that would be a good starting point.
Absolutely, it would probably save a lot of time.
Yeah.
And the only development necessary would be the actual connection to the external data source.
Yes, exactly. Yeah.
I have some questions. Can you guys hear me?
Yes, go ahead.
Yeah, so this is Nicholas, and I'm that business guy that someone was talking about just now. So, because I understand some of this, right? I've been helping companies with stream processing and event-driven architecture from like the business aspects, because I see the benefits, and doing actual presentations about blockchains and all these kind of things, right? But I think for this one, to understand the linkage between what the problems are in real life, as in the use cases, and just going from version 1 to version 2 of why that is important, that would definitely help me, right? I mean, to understand what these changes are and what that actually means for solving real world problems. But in terms of the technical stuff, So, and yeah, forgive me if these questions, maybe you already answered them, but are you basing this solely on Azure, or are you setting up like this event-driven architecture with, I mean, stuff from Apache, like Camel, Spark, and these kind of things as well? And is it Kafka-driven at all? I didn't really hear about Apache Kafka at any point in time, so I'm not really sure if that's what you're using or if it's RabbitMQ or something else. But I mean, can someone just answer that, or if the question actually makes sense? I'm just thinking about sort of the lock-in effects of just using Azure. And then again, which comes to like the other question is, can this be deployed in any cloud, like AWS or anything else except for Azure, from a business perspective?
Yeah, I understand your point of view. This meeting was intentionally highly technical, focused on technical sides and not so much on the use cases and reasoning why we actually have gone to version 2, for example.
Yeah.
And no, this solution is not intended to be deployed anywhere else than Azure. So this is not for AWS or anything else. This is as a service. Obviously, you can do it, but it does require a significant amount of work.
Okay. No, because that's good to know, right? I mean, for me, who's out there talking to people, and then they say, I mean, I've been saying, of course, that you can deploy it anywhere. It doesn't really matter. But then that is a limitation, or well, intended one at that, right? But that goes back to, again, like the choice of not going maybe then with, well, Apache Camel or Kafka. I mean, that's the aspect as well. Is it Kafka based, or is it, because this is what I see is like an event-driven architecture, stream processing. You have the connectors on both sides, all these kind of things. Can someone elaborate a little bit more on that one, just from a curiosity perspective?
I could basically comment on that if it's okay. So just a few kind of views on the business side. So yes, to my understanding, you can correct me if I'm wrong, but basically that said already, it is an Azure-based system, and the open source stack, so to say, on that one, using Kafka and all that, is an alternative way to build the same thing or similar thing. Then the question of why using a stream instead of the request and response, that should be obvious. So that's
yeah, I got that part. Yeah, exactly.
Yeah. So basically, actually, it's important, and it's kind of a very natural evolution or even revolution when people start doing this kind of highly, a lot of data being bounced around, they usually end up in the streaming anyway. So that's the kind of natural evolution.
No, okay. I mean, good stuff. I mean, I think that answers. I mean, so you are using it indirectly, so to say, by using Azure, their stack, and of course they're using Kafka at the bottom. No, I understand these parts. I mean, I'm talking to a lot of these companies that are using streaming platforms, and I'm talking to Confluent on a pretty, so like a monthly basis, and also Foghorn, and a lot of the companies that are using stream processing at scale.
And as for the Kafka question, actually, the Microsoft's service bus is their own message queue system, kind of like Kafka, and it's using AMQP for messaging. So there is open source implementations of that.
Yeah.
Yeah, to my understanding, Kafka is Microsoft is not using Kafka. So it's
no,
they're not. Okay.
Yeah, it is their own message queue.
Yeah, as Kimmo said, it's an alternative way to do similar stuff. So this is purely on Azure capabilities and functions based solution. So you can do it. You can do it with different kind of technologies, and this is one way to do it. So
yeah, but from a business standpoint,
obviously we can build a connection between Kafka based and this kind of platform. So that would be interesting, and that's where we are going anyway. So platform to platform communication is the next step anyway.
Okay. But from a business perspective, from my perspective, just to understand this, then when I talk to potential customers and they say, well, we run everything in AWS and we want to use Platform of Trust. The previous one, version 1, was that sort of more cloud independent, or has it always been tied to Azure? Or is it only quote unquote version 2 that is tied to Azure?
Yes, this is a good thing. Good question. The previous version was more, let's say, agnostic version.
Yeah.
We made a decision, a strategic decision, for the sake of cost effective and performance-wise, to actually take advantage of Azure as much as possible.
Yeah. Okay. Good. But then I get, because that's very, very important for me to understand. So otherwise, it's the classic: I sell them on something, and then then you say no. This is Azure based, right? We can only plug and play in their environment. So I think that's from my perspective is very well. It's very interesting.
Okay.
Okay. Good. Thanks so much.
Any other comments, questions, or should we go to the last step of next steps? Known what's gonna happen. And if you don't have questions now, keep in mind that you can always contact me, for example, in email or even phone. I might not answer the phone. I kind of keep it silent mode mostly. So probably email is the most certain way to contact me first, and then ask the questions. But if there are no questions anymore,
I have one question.
Okay, go ahead.
So basically, very short. I know this can be a long discussion, but have you made any decisions on the ontology side, or will you kind of go on with the current plan?
Yeah, I kind of expected, Kimmo, this. So. You know that this is a painful thing. So you keep on bringing this up because it's painful for you too. So we're both having the pain. In my understanding, the decision has been that we will stick with the current solution, and we will find a way to reduce some of the pains caused for the developers and consumers, and the inflexibilities that it actually might bring or brings for expanding the ontology. So working on the process and tools and ways to expand the ontology more scalable way is something that we have been working for already now. So we're not going to change away from linked JSON LDs.
Okay, thank you.
Yeah, that was actually my question as well, but I wasn't sure if it was the right forum. But I'm now going to ask as well, right? So, because it's called Platform of Trust, and I mean, before or even since the beginning, I mean, I talked to you, Jarkko, and to Tony as well, and also pushing this out to customers because again, like I'm a business sales guy, strategy guy, or whatever I am, right? So, and I say, of course, this is data you can trust. We have an ontology based, all these kind of things. What is this? Because I didn't see that anywhere in this architecture. Not really, at least. I heard someone just say briefly about knowledge graphs. I guess that was more for the scalability aspects. But where does is that where what it was meant with the translation part, and how scalable is it in volume? Because that's what we're talking about when we have an event-driven architecture, right? And I think because that's what I'm seeing companies that want to connect. Of course, they want to start with 1, 2, 3, 4, 5 different APIs, but then they have 100 internally, and then they want to get more from the real world, so to say, and then get more hundreds, and that's where the data harmonization place comes in. So what is the status, or because I heard something in between the lines, but of course I haven't been privy to the discussions of what has happened, what will happen. But just please briefly, because this is very important for me, because it's I mean, that's one of the things that I'm pushing. The harmonization part between different APIs, and to get that one API so that companies can create these data products. So if you would allow me, if that's okay, if you just can briefly go over that.
That hasn't changed a bit. So we're still doing the harmonization. It's a question that where it actually happens. In the version 2 architecture, there's two possible technical solutions that where it can happen. It's either inside the platform of trust, or it's in the connector component. So harmonization is going to happen anyway. And when you're developing a connector which actually connects any kind of data source to platform of trust, you're normally in that case also doing the first data harmonization rules in the connector component as well. So the transformer component, as it has been in the pictures or function. Yep. So that's not going to go anywhere else. That's going to stick. The only change is now that where that actually happens in the architecture.
Yeah. And what sort of requirements do you set on, or do you set any requirements for the organization pushing the API? Because I had some questions about that regarding where that is going to happen. Basically, the stuff that you've done now with Polku, that they've done it sort of outside of their realm right now, and you want to sort of absorb it within Platform of Trust. I understand that perspective, because I think like a lot of the companies that I'm working with in the traditional space, their APIs they're not great. The data that they're pushing out is very, I mean, it's not really standardized. It comes in very, very different shapes and forms. Do you put any requirements to them as well to change their side, or is everything done at Platform of Trust side?
That's a good thing. The flexibility comes from the connector component, which sits in between. So that is adapting to customer system inflexibilities or inconsistencies or whatever. So basically, so far, we've been giving the requirement that the data source system must have an API. So any kind of direct integrations to database hasn't been done, even though I think it was Jarno who said that that's one possibility. Yes, it is, but that would be like doing the old-fashioned integration, and I don't like the idea. Exactly. That's personal opinion, but I would rather have the API requirement there. As long as you have an API, let's say a REST API, SOAP API, MQTT, whatever protocol you have, gRPC, whatever, and then the connector component. The architecture already is so flexible that it's kind of the protocol switching is a plugin based solution. So we can expand it. So that is adapting. The point is that we don't want to create additional barrier for any kind of data owners to be interested about Platform of Trust by introducing a need to adjust some kind of well-established long-term solutions. So that's why the flexibility is built into connector component.
So the basically then, to summarize or to understand it from my perspective, is that the connector then does some kind of triage or pre-cleaning or whatever you want to call it, and then sort of like the harmonization part is more inside Platform of Trust. But the next question, of course, when you you have all the data, you want to do analytics, you want to do, well, you create the data products. Do you have anything like around metadata tagging or anything like that? Because that's one of the biggest issues, of course, in building automation.
Let me maybe answer this question. This is Roman.
Yeah, that's good.
Yeah, so how actually harmonization works from customer perspective and how it looks like. So when you have data coming out of connector, each data piece is extended with link to metadata data definitions. So having this link inside the data, any parser can go to that link and get all the metadata associated with data included in actual response or actual stream you receive. So this is how it works. So you have link with metadata descriptions and all the definitions, field limitations, lengths of string types, and so on and so on. And this is all included in the data you receive from Platform of Trust.
Yeah, but that's from the endpoint, right? I'm more talking about sort of the ingestion process. And then you say like it's being linked to or metadata data tagging standards. Is that like Haystack, Brick, or is that where Platform of Trust, your sort of framework ontology comes in to match it against that one? You understand what I mean?
Sorry, not very much.
Okay, so for the ingestion process, when you have running the connectors, and then you say, well, you're mapping it against metadata tagging standards or metadata tagging frameworks. That's the part. I mean, maybe we can have a separate discussion about this, because maybe every one of you knows about this. But this is something that I would need, or I would like to understand a little bit more clear, because these are the discussions that I have, especially in building automation, where again, metadata tagging, I mean, Brick Schema, Haystack, IFC for BIM perspective, or REC from Sweden, those are the discussions that I'm in. So either if I can have someone on your side to join me on those discussions, if that would be even more helpful, or just to have like a primer in how it's being done, if that's possible.
You can ping me, Roman Savran, on Slack, or we can have, because I'm like doing this ontology stuff from technical point of view.
Okay, perfect.
So just one small comment. I'm not sure if I answer any of the questions you asked, but in transformer component of connector, what it actually does, it adds links to the metadata description and then ensures that the data the transformer puts out is aligned with those metadata structure. And this is how customers then can parse this data or understand what it is about.
Yeah, so that's how they can create these data products and to understand like the linkages between them, even though it comes from different sources.
Yeah.
Okay, good. Thanks so much.
And the actual data product it contains elements for business, but also it defines also the payload stream schemas and so on. So basically, it standardizes not only the data itself, but also the needed business elements of the data product itself. So
yeah, great.
All right, good topic, and please, yes, contact Roman, and if and Panu probably wants to be also in the discussions because Panu Pitkänen is leading the ontology development, and Roman is his technical side.
Yeah, Panu actually reached out to me on LinkedIn just now, so he's very predictive, prescriptive, so that's good. Event streaming 101.
Excellent. So. The final thing for the day is to see what's going to happen next, and I collected some of the things that I see that how we're going to go forward, and now you should see the last slide, not in the presentation mode because I don't know what's going to happen then. Next steps during the Q3, so ongoing quarter, we'll finalize the V2 connector and platform architecture so that we can say that, hey, this is how it will go. Of course, there is always development, but we will have some kind of an example how we want the development to happen and how everything should go. So and we also need to define the CI/CD process and practices. So for example, how to deploy the connectors in Azure environment. So far, we've been using in version 1 the containers, but let's see what is the technology for the version 2. We are tempted to say that version 2 connectors should be node driven and should follow the example code that we actually provide and you modify it. That would simplify our job. That would simplify the management of everything. That would simplify also the development side of those because you would be contributing whatever new innovations you do in plugins or something. You would be contributing to the already open source solution of the connector. But that hasn't been yet decided finally, but my gut feeling is that we will actually push everyone to use the same connector skeleton for the next connectors. If you have strong opinions on that and you don't want to do that, please send me an email or something, and I'll discuss and I'll take into account every aspect of it. Some of the V2 connectors are already in the pipeline. Those are always labeled as V2, and there's a couple of examples now. Some real-time data sources for the traffic, and some other solutions related to some of the customers, which we actually want to onboard directly to V2 without going through the V1 at all. And that we want to develop the first connectors already to some real customer-focused cases, and that's going to be implemented Q3 and Q4 this year. And starting from Q4 already this year, aim is that 80% of the connectors will be developed on V2. So get ready for the requirement that everything is going to be in the new architecture format. And if you don't want to invent everything again, reuse the architecture solution, build and test it solidly with 15 different cases by the Polku Innovations, and it's the node-based solution. Too bad if you don't know how to do any node-based development. Sorry. And then selected connectors built for the version 1 will be updated to be included also in the version 2, but that's going to start probably beginning of next year. And we are now in the process of getting a connector engine manager. So far, I've been running the connector engine from the even before it even existed. So I created it and I started running it. But now I need to focus on other things, and still this is now going forward and doesn't need so much of my expertise. So we are moving this to a dedicated manager, and probably starting in a week or two. And it's more of a technical person, and will be responsible to refine the work packages that come in from the salespeople, so that all the necessary information should be there, and refines the information, collects more information, probably even defines the mapping of data source system content and the desired output package or payload, and then manages the whole process, and also does at least some of the reviews of the connectors. So one of the bottlenecks has been the review process. This should help in that also. So that's what's going to happen next. And any comments, any takes on this? Everyone is silent. Either horrified or
it's crystal clear.
All right. So that's it. We went 3 minutes overtime. Sorry for that. And again, if you have any questions, contact me, Jarkko.Moilanen at oftrust.net, or call me, or try to ping me in LinkedIn. And that's it, basically. Thank you for all the presenters, Jarno, Adrian, and now I lost the name, Arto, yeah. And thanks for the comments, and thanks for the participation, and have a great day.
Thank you to Jarkko for organizing.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye.
Yeah, thank you. Good. Great job, everyone. Thanks, Jarkko.